I'm a senior application engineer at Google. I've got 16 certifications in the Salesforce ecosystem, including applications and systems architect. You can find me on Twitter at Mitch Spano. You can email me at my work email, mitchspano@google.com. Today we're going to go ahead and get started and share how we as a Salesforce customer use our Google world-class infrastructure to enable DevOps on the Salesforce platform. Just a little bit of housekeeping things. If you have any questions, there's going to be a couple of times where we pause throughout the presentation. And then at the very end, we'll also have additional opportunity to ask questions. So if you have questions, make sure to put them in the chat, and then Amit will be relaying those questions to me throughout the presentation. And hopefully we can get any questions or queries that you have answered. All right, so what are we going to be talking about today? There are a few things that you should take away from today's discussion. Number one is we're going to talk about DevOps methodologies and goals. So what is DevOps? What problems does it solve? We're going to talk about some of the methodologies or ways that we like to think about DevOps at Google. And we'll also kind of introduce some challenges that are particularly unique to the Salesforce platform, as opposed to DevOps on other platforms if you were building stuff in, say, Python or Java or any other technology stack. Then we'll kind of switch gears and we'll talk about how do we do it at Google. So, Google has a lot of Salesforce use. We've also got a lot of really cool infrastructure. So we've put together some pretty cool DevOps pipelines from scratch, and we're going to share with you how we did it. So we'll talk about branching and sandbox strategies to help you get started as a customer of Salesforce. And then we'll also kind of walk you through a sample changes lifecycle to understand, okay, a developer makes a change, then what happens next? What happens between the authoring of the change and it going live in production? And then we'll also talk about some really helpful mechanics that we've built that anybody can build that will help you improve the quality of your DevOps pipeline, particularly on the ops side. So helping you operationalize the things that occur when you are interacting with your DevOps pipeline. Then finally, we'll kind of give a little bit of a vision into future endeavors. So these are a vision into our team's current roadmap, and then some open challenges for the Salesforce community to tackle together. So let's dive in. So definitions and goals. What are we talking about here? We've all seen this DevOps infinite loop infinity symbol here, and I just got to tell you, that is not what we are talking about today. So what we're talking about we're not going to be giving like marketing kind of things to just give you like this vague definition of what we're talking about. We're actually going to give you explicit, direct things that you can use within your pipeline. So the goals that we want to accomplish include, we want to reduce all operational overhead. So from the time that a change gets written to a time that a change is live in production, and then after a time is live, after the change is live, and when you're monitoring and supporting that change, we want to reduce all developer operational overhead throughout that life cycle. Another goal that we have here is we want to safely automate everything. So think about every single piece of your process. Every single piece should be viewed with the lens of how can I make the computer do all or a portion of this for me. So these are things like executing code review, making sure that everything deploys safely and that all of your tests are ran correctly, deploying the change up to the target environment. All of these things that your team does, producing documentation, right? You need to view them all with the lens of how can I make the computer or the robot do the lion's share of the work, and then enjoy all of the fruits of that labor, so that way we can improve the delivery velocity and quality of what our engineers are putting out. Another thing that you'll hear is that we want to shift all breakage left. So you may have heard this term before, but what this means is that if you look at the timeline of a life cycle's change going from left to right, left on my side, right over here, if you imagine it as a timeline, we're trying to shift all potential breakages and catching all errors to the leftmost side of the timeline as we possibly can. So that means that if you were to write a query within a loop, right, that could break within production as soon as you exceed the query limit, but you could probably catch that with static code analysis and catch that right away during your development, and therefore shift the breakage completely left and decrease the cost and level of effort to resolve that issue before it ever propagates to a higher environment. And then you'll be able to decrease the burden or challenges that you potentially introduce to your users. Then finally, what we want to talk about is scaling with team growth. So I'm sure that folks in the Salesforce ecosystem have, worked on a small team of folks, and you're all trying to develop in a shared sandbox. I mean, that only works until you have about 4-ish engineers in the sandbox. Then you start overwriting each other's files, and things just get hairy, right? So in some of the world's largest Salesforce orgs, you have 100 plus engineers working in one org. So how are we going to use tools and practices to scale our operations with the team growth to make sure that our customers are satisfied and that our application is as robust and supported as we need? So these are kind of some of the goals that we're talking about here, and you can see how a lot of the mechanisms and tools that we'll be using will align with all of these goals that we've enumerated. Okay, so what does DevOps look like on the Salesforce platform? We're going to grossly oversimplify this, but over here we've got Ruth. She's our architect and our developer. She's making some features. The first thing that she's going to do is she's going to propose a change to a repository. And at the time that it gets proposed, we execute what we call a pre-submit job. So pre-submit job does a lot of the code quality checks for us to make sure that the proposed change is valid and is not going to break anything. We'll get into all these details later. Then she'll check it into the repository after it passes the pre-submits and code review and all of those other things. And then after it's in the repository, there will be a second job called a deploy job that'll take the contents that were checked in and deploy them to the target Salesforce environment. This is oversimplified, but it's oversimplified on purpose because in reality, if your process looks more complicated than this, you might want to try to ratchet it back and go back to basics, because your process shouldn't be more complicated than this. It really should be as simple as it possibly can be to make sure that new teammates can come on board and get up to speed, make sure that there's less opportunities for breakage throughout your pipeline. This is really what DevOps is kind of at its core supposed to look like. So we want to keep this oversimplified on purpose. All right, Google's methodologies and tools. So here we've got a couple of things that are really important to share. Number one of them is Piper. So Piper is a source code repository that we use at Google for the overwhelming majority of Google's products and services that you may be familiar with, and then a lot of them that you're not familiar with. Piper is the world's largest code repository, and it's a huge mono repository. So instead of having separate little individual Git repos for all of your projects across your organization, there's only one repository, and it is gargantuan, billions of lines of code. Okay. And when you have all of these folks, hundreds of thousands of engineers working on multiple projects, billions of lines of code, it's important that we enable what we call trunk-based development. So what that means is that you always commit to the tip of the main branch. And then what you'll do is you'll have a historical commit be selected as what we call the release candidate that'll be compiled into a binary and then deployed to your app servers at a future date. So what does that look like? Here's a little animation, right? So I'm an engineer. I'm making commits to the main branch. And then at some point, we'll choose a historical commit, and that'll be called release version 8.1. Then you continue to make commits onto the main branch. And then at another point, when you're ready to do another release, you choose a historical commit, and that becomes release 8.2. So this is how Google operates at the scale of Google. Trunk-based development enables you to have a lot of folks working in a repository, and you don't have all of the challenges that you would have with merge conflicts when you're doing like a Git-based or branch-based development workflow. When you do this, though, however, it's important to note that all of your features must be hidden behind a feature flag. So a feature flag is something that is basically like, think about it like an if statement in your code that says, if the user has this feature enabled, then execute this code. So that way your code can be compiled and pushed up to prod, and then your features are enabled at a later point after that feature flag is assigned to them. So this is a really important thing that we do, and it enables us to segregate our technical deployment from our business go live. When you're operating within Piper as well, there are enterprise-wide coding standards that are applied. So we have these really robust code analysis and formatting checks that are executed whenever somebody raises a proposed change. And then there's also this concept of privileged submission. So this means that we have language readability requirements. So for example, I'm a Salesforce engineer. That's my area of expertise. But I might need to write some sort of tool that may be built in Java or Python. When I raise a proposed change that is in the Java programming language, I need to have that proposed change reviewed by somebody who has earned what we call Java readability. So that means that that person has written enough Java, they're familiar enough with the enterprise-wide standards that they can tell you if you're adhering to those standards or deviating from them. And then finally, when you're in a mono repository, you need some sort of concept of project ownership. So that means that basically within the folder structure that you're proposing a change in, there's a specified owners file, and the owners of that project must sign off on or approve your proposed change. So that's how we make sure that individuals still retain autonomy and control over their projects, and all of that is built in for you. So that's what Piper work looks like, and it's really, really incredible from a developer's experience. It's very frictionless and amazing. So that's one of the methodologies that we use at Google. Another methodology that we use is very familiar to folks. It's called Git, and we have an internal code review engine called Garrett that runs on our server infrastructure, which is called Borg. So some of these terms that we might be discussing today are Git, Garrett, and Borg. But this is just an internal scalable Git infrastructure that supports multiple bespoke Git repositories and and branch-based development. So for example, in the main difference in branch-based development is that you'll have a branch that holds your features, and your releases are not done from historical commits, but they're done from merges. So for example, at some point we'll create a QA branch, and then we'll add some features to it. Then when it comes time to do release 8.1, then we'll merge that branch back into the main branch, and then that's how we do our release. Then we'll cut a new QA branch, we'll add some features to it, and then at a later point in time, we'll merge that back in, and that would be release 8.2. So a little bit of a difference in the development workflow, but we do have both of them are supported. So for us on the Salesforce side of things, we use Git and Garrett on Borg for a few reasons that we'll get into in a moment here. But the good thing about that is that means that any of the things that we're going to be talking about today can be easily replicated in the open source world. Everything that we're going to be discussing can be emulated if you were using GitHub and GitHub Actions or Bitbucket or GitLab or any of these Git hosted providers. So these are kind of the two coding paradigms when it comes to repository and workflow management. All right, so there are a couple other tools that we might talk about, or some terms that we might share in today's presentation, but you probably won't recognize them. One of them is called Buganizer. And Buganizer is our internal ticketing system. Think about it kind of similar to Jira, but this is where really all of our engineers work. Every ticket is a bug. So even though it might be a feature request, it might be a story, it might be something else, it might be internal cleanup, we call all of them bugs because they exist within Buganizer, but really it's just a ticketing system. Another thing that we might talk about, or that we're going to talk about, is called Kokoro. And Kokoro is a build tool that's very similar to Jenkins or GitHub Actions in the sense that it will kick off shell scripts that live within your repository whenever code repository events occur. So this could be something like a change is proposed or a change has been merged. When those two events happen, we have the ability to kick off some scripts that will perform some actions for us and help facilitate our workflow. Okay, cool. What are the DevOps challenges that are unique to the Salesforce platform? There are quite a few challenges that are unique to the Salesforce platform when you're talking about DevOps. And let's take a look at some of them. There are challenges all over the place, but here are some of the main ones. Now, number one biggest challenge is that Salesforce does not compile to binary. What you check into source is actually an XML representation of the things that you've configured in the setup menu alongside your Lightning Web Components, Visualforce pages, and Apex classes. So what that means is that it enables kind of an incomplete source representation. So we could have stuff that exists within the org and stuff that exists within the repository, and they could not 100% align. That's very not intuitive to folks that have been working in traditional software development stacks, because if it's not in the source, it doesn't get compiled into the binary, therefore it does not exist. So it's challenging because this means that us as Salesforce customers must actively work to ensure that there are no discrepancies between our source and the target environment. That's one of the biggest challenges that we have within Salesforce DevOps space. Another thing that's kind of unique about Salesforce is that there's no native environment variable support. There's no native feature flags, and there's no such thing as like A/B testing or phased rollouts. So what this means is that it kind of forces our hand to have these long-lived sandbox branches. So we'll have a sandbox branch, or a branch within our repository that corresponds to our non-prod or QA sandbox, and then our main branch corresponds to our production environment. And then if we wanted to commit a feature to the QA branch, for example, we can't exactly easily merge that into our main branch because there's a whole bunch of stuff that's supposed to be unique to the QA sandbox, and it makes a Git merge pretty much impossible. So folks who may be familiar with a traditional Git development workflow on a separate technology stack might find this a little bit weird. And there's some things that we have to do that are unique when we're working within the context of Salesforce. Finally, there are metadata API limits, and there are no unique rollback mechanisms, right? So this really makes disaster recovery and org versus source reconciliation quite a big challenge. So for example, metadata API limits, if you have above 10,000 components within your project's force app directory, then you can't deploy them all in one go. So it makes it kind of tough. These are some challenges that are going to need to be resolved for us before we can carry on with making a robust DevOps pipeline on Salesforce. So before we get into the actual tools that we're going to use here, I'm just going to take a moment and pause. Amit, do we have any questions in the chat that I can answer at this time?
There are a few questions, but you can keep going. I will report that once your relative topic will become.
Okay, excellent. That sounds great. Awesome. I'm going to carry on, and we're going to go ahead and we're going to talk about some kind of strategies and some tools that can get you started. Okay. So how it's done at Google, strategies for success. Now, keep in mind, this is going to be particularly applicable to org-based development workflow. We at Google, we're a Salesforce customer, right? So we've got an org that our users are using. We've got people live in there at any given time. And we imagine that that's probably the scenario for most folks in the Salesforce ecosystem. But however, a lot of this stuff is still applicable if you're an ISV. So there's definitely still going to be a lot of good content to learn. Cool. Branching and sandbox strategies. This one's really important. I think that folks have a lot of challenges with this, but the overall scope here is that you want a simple setup and that less is really more. So what we're kind of looking at here is a diagram that kind of shows a little bit about a change's life cycle as you interact with your sandboxes and with your branches within your Git repository. So one thing that you'll note here is that we have this term CL. CL stands for change list, and that is something that we internally at Google call a proposed change. So it's basically the same thing as a pull request if you're familiar with a GitHub workflow. So you might see CL, it's analogous to pull request. Okay. So within this simple sandbox and branch strategy, our recommendation is that developers will work in their individual sandbox or in a Scratch org if you guys have Scratch orgs enabled, and then they'll create a CL or a proposed change, and they'll raise that as a proposed change to the QA branch. Okay, when that pull request or that CL is created, at that time we'll kick off a validate only deploy and execute all tests in the QA sandbox. Okay, then when it gets merged, we'll actually do the deployment itself. Okay, so that's what I mean with the pre-submit job versus the deploy job. Okay, so pre-submit's in yellow, the deploy is in green. Then you go through and you're in the QA sandbox, you test the features, you get sign off, everything is all good. At some point, it comes time to promote those changes out of your QA sandbox and into prod. You'll do what we call a selective promotion from QA to prod. Now, selective promotion, it means that you're choosing a subset of components to be moved from the QA branch to the main branch. Recall that we can't easily, in most Salesforce situations, we can't easily do a git merge as our promotion mechanism. So a lot of times you'll use a git cherry pick, where you'll cherry pick the exact lines that have changed and the exact files that have been touched in that particular CL or commit. Or sometimes you can use you'll just use the git checkout command to check out explicitly the exact files that you're looking for from the QA branch and then propose them as a change to the main branch. And when you propose that as a change to the main branch, you're creating a second CL, which is basically like a merge request. And we'll do the same thing. We'll kick off our pre-submit job in yellow, which will do a validate only deploy and run all tests in prod. And then when those changes actually get merged, we'll kick off our deployment job that'll actually deploy those changes to the target environment. So again, less is more here. The more sandboxes that you have, it means the more branches that you have. It means the more copies of the code base that you have. It means the more manual steps that you have to promote your changes up the line. So we really strongly recommend that you use as simple of a process as you possibly can to facilitate your workflow. Okay, so the path to source is an uphill challenge, all of the necessary requirements. Okay, so what we're going to be talking about now are like a lot of the things that happen during the pre-submit time. So as a change list or CL is created, then what we're going to do is we're going to run some code quality checks automatically. Then we'll do that validate only deploy and run all tests. Then and only then will we perform code review.
So there is a question, does all the test classes run during the pre-submit, or do we have to select the specific test run at the run?
Excellent question. Excellent question. I would always strongly recommend running all tests every single time. So the reason why we write tests is we write tests so that way they're kind of the breadcrumb trails that give future developers the knowledge about how the code is supposed to be executed. And when we execute those tests, we make sure that our proposed changes are not breaking anything that we've historically delivered. Now, I understand that that's kind of a challenge to do sometimes. A lot of folks in the Salesforce ecosystem have tests that take a very, very long time to run. If you do that, I definitely would recommend checking out a previous Apex Hours video that we put together about, it was titled Pure Unit Testing in Apex, which will share with you some strategies that will speed up the test execution of your Apex tests. That's definitely a really applicable tool. However, if you are in a situation where you only run a subset of those tests, I would make sure that number one, you automatically run all tests for anything that's included within the change list or pull request. And then also two, you give a mechanism whereby folks via the commit message can enumerate additional tests to run. And then three is you always want some sort of a mechanism within your pipeline to say that there could be a subset of tests that are always ran no matter what. So if you're doing a partial execution of tests, you probably want to have those three particular mechanisms in place. Automatic execution of any file that is a test file that's been within the proposed difference, some sort of commit message mechanism whereby folks can enumerate additional tests outside of those ones. And then a standard like baseline, we always run these set of tests just to make sure that there are certain things that are in your org that are configured the right way. So we create the change, we execute these automatic code quality checks, we run the tests via, a validate only deploy, or maybe we'll create a scratch org and then run all tests in that scratch org. If your team has enabled scratch orgs in your workflow, and then and only then we'll do the code review. The reason is that if your code does not run tests successfully, then you as an individual contributor or engineer, you still have some work to do. You shouldn't bother a senior engineer quite yet to perform a code review because you're not done. Same thing with the code quality checks. If you don't pass a code quality check, then there's no point in having a senior engineer review your code. So by forcing the successful passing of code quality checks and successful execution of tests as a pre-requirement before code review, you're actually going to be able to get a better value out of your senior engineer's time throughout the entire application lifecycle development process. And then finally, when it passes all the comments, you and your colleague have gone through and debated, hey, this variable name is weird, or whatever it is that you define within the code review. Then once all those comments are addressed and you get the approval, then you'll do the merge. So as you go up this uphill challenge, you're gaining more and more confidence that the proposed change that you have is actually safe, valid, adheres to all of the organization-wide standards that you have, does the thing that it's supposed to do, and it does not going to break anything that you've historically delivered. Okay, so let's talk about some of these pieces within the pipeline. The first thing we're going to talk about is these quality checks. Quality checks are fully automated within our pipeline. The first thing that we're going to do is actually rather simple. Is we're just going to check for the existence of a bug ID. Remember, bugs are tickets within our ticketing system called Buganizer. And we just basically check to say, hey, do you have a ticket ID within your commit message for the change that you are proposing? If not, we're just going to fail the change right away. This means that developers have to have all of their work represented within their ticketing system before they can make changes to the repository. Okay, that's just a simple regular expression check. We'll go into deep detail on all of these, but these are kind of the 4 main steps that we have within our code quality check. Another one is that we check formatting. So if you propose a change that contains, say, a class, and that class is not formatted using Prettier, that the job is just going to automatically fail your change and say, hey, you need to format this file. Another thing that we do is we execute static code analysis. So for those of you who are in the Salesforce ecosystem, you might be familiar with PMD, the Programming Mistakes Detector, probably as an extension to Visual Studio Code. For those of you who are not familiar with it, PMD is a static code analysis tool that will highlight errors or warnings that are caused by the actual structure of the text that is in your class file or your trigger file. So normally folks do that within Visual Studio Code. However, we do that as an automatic code quality check. So if you have PMD violations, those can force a halting or a failure of the pre-submit job. And then finally, we have this additional construct called Salesforce readability. So it's an additional layer of quality to be applied to the change list process. And that just is kind of like what we were talking about before with Java readability. We have this thing called Salesforce readability. It just means that somebody who's earned the credential is going to take a look at the code and make sure that it adheres to the enterprise-wide coding standards. So let's dive into each one of these automated code quality checks. So bug ID check, this one here we've got a sample change. I've got the commit message as hello world. We've got this class is what we're proposing as a change. What we're going to do is we're just going to do a regular expression check and say, hey, do we have a ticket ID in this commit message? And if not, we're going to say, wait, there's a pre-submit error. No bug ID was found in the change subject hello world. This one's pretty simple to implement. Just use regular expression. Make sure that it matches the ticket number format of whatever ticketing system you're going to use. And if they don't have one in the commit message, then fail the pre-submit. Okay, so now they make a modification and they add the ticket ID, But the next thing that we're going to do is we're going to do the formatting check. So they get past the ticket ID check, but this class is still not formatted. So within Kokoro, this pre-submit job is going to run, and it's going to say, oh, wait, this file's not formatted. We'll generate a comment in line on that class and then expose that within the code review tool. So I raise a proposed change. It kicks off a Kokoro job. A handful of minutes later, it comes back and it writes these comments directly on the files that I'm proposing a change to, and it says, hey, please format this file. Okay, so now the engineer has said, all right, I'm going to go ahead and they pull this back down. They make a modification to the commit. They format it using Prettier. This is where the PMD scan comes into play. So what we're going to do is, now we've got this, the commit message is fine, and now the class is formatted. But what we're going to do is we're going to run PMD, and we're going to take all of the findings that are found as a result of the scan, and we will generate comments in line directly in the context of what rule tripped up that requirement. Or excuse me, what line tripped up that rule within PMD. And we'll generate the comment in here along with a hyperlink to learn more about the rule itself. And certain ones of these errors can be defined as halting errors, meaning they will actually stop the job. So we treat some errors as errors, and some of them are just as warnings.
So there is a question. So if somebody will commit 100 times, they have to put the ticket number every time.
So if you it's just within the commit message. So for us, the Garrett workflow is a little bit different because you actually just keep amending the same commit. It's a little bit different than GitHub. If I were to recommend doing this in GitHub or Bitbucket, I would probably say the pull request name must contain a ticket ID, not necessarily the commit message. For us, a commit is just one. It's basically the same thing. The CL only ever contains one commit.
So there is also one more interesting question: how much time it take to finish one validation job end to end, assuming everything is correct?
That's a good question. So that's going to depend on your org and depend on how long it takes for your tests to run. For us, the whole end-to-end thing, if we run all of our tests, takes about 30-ish minutes. And so what we do is we do that dynamic test execution when we're committing into our non-prod environments, and we do the full test execution when we're going into our higher environments. So that 30 minutes, about 26 or 27 of that is just test execution. So if you were to limit the test that you execute to only what's included in the scope of the proposed change, this takes less than 5 minutes to do this entire thing. Great questions, by the way.
Yeah, keep going.
Awesome. Excellent. Yeah, so with PMD, what we do, like I said, is we'll generate these findings. Certain ones of them can be errors, certain ones of them can be warnings. The errors, we append this little emoji header that says, hey, wait, this error must be resolved before continuing. Any of the ones that are just warnings, we omit that header, and we just raise the comment as like an FYI, hey, there's an opportunity to improve. And you'll see here, so here's our submit requirements. We'll see that all comments are resolved. I've got Salesforce readability, but Kokoro job has failed because of these PMD violations. All right, and then finally, we'll talk about Salesforce readability here. So this is an earned credential to enable approval of source Salesforce project. So at this point in time, we've got a change list that was created by my colleague Krishna. Kokoro passed, all of the validation was good, the test ran successfully, the PMD scan was fine, but he does not have Salesforce readability. So the Salesforce readability is not satisfied quite yet. If I were to raise a change, I have earned the Salesforce readability credential, so it automatically checks for me that it has been done correctly. And then when I perform code review on Krishna's change, the Salesforce readability requirement is satisfied. So Salesforce readability is a process, and basically our readability requirements are you need to have either the Apex Advanced Apex Specialist Super Badge or the Platform Developer 2 certification, and you need to have written at least 400 lines of production Apex code. And we don't include things like comments, structs, or anything like that. And then what we'll do is you'll propose to say, hey, I want to earn the readability credential. We'll review those 400 lines along with their associated tests. The tests don't count towards those 400 lines. And then the folks who have earned the Salesforce readability credential will take a look, and then they'll review your code. If it passes all of the enterprise-wide standards that we've agreed to, then you'll have earned the credential. So readability is a really important thing because what it does is it propagates the knowledge of the enterprise-wide coding standards across all of your teammates. So kind of think about it as like a little bit of like a training period per se for folks who are maybe new to the organization and who, like I said, have not been exposed to those coding standards that you have. It's a little bit of a training period just to make sure that they're following the standards that you and your organization have put forth in the past. And I'm happy to say that since this screenshot has been captured, Krishna has definitely earned the readability credential. Awesome. Okay, so now we're going to switch gears here. Well, I guess before we switch gears, are there any additional questions that we have on the code quality checks that we just went over? Okay, we'll carry on for a little bit here. Again, if you have questions, please put them in the chat. Amit will let me know if there are additional questions, and then we'll raise them as they come up. And then again, at the very end, we're going to be answering any questions that may have accumulated. So now we're going to switch gears here just to share some helpful mechanisms that we've built to navigate the nuance of Salesforce DevOps. So there are some things that we've built that I think are pretty cool. Number one is dashboards and reports. What we can do here is we can create a deployment system health dashboard that gets automatically generated every single time you deploy your components to your Salesforce org or run a pre-submit job. So folks who are using Git and maybe have maybe already have an automated deployment pipeline, you're using the SFDX force source deploy command to initiate the deployment of components within your force app directory or any directory that you're operating in to your target Salesforce environment. Not many people know that you can take this force source deploy command and you can add the -- JSON parameter to it to output the format of the deploy results in JSON format. And then you can save that to a JSON document. So what we're doing here is we're saving deployment artifacts, and then we'll take that JSON format and we'll transform it into a deployment health dashboard. So here we've got the deployment health dashboard for the trigger actions framework. So at the top, you'll see basically this whole thing is just a couple of tables, right? You'll see the total number of tests executed, the total number of tests failed, the total time in milliseconds, and the total time in minutes, right? So just kind of overall header level information about how long your tests took. Then we'll switch into another section where we organize all of the classes within your repository, organized by their total number of uncovered lines. So here you'll see that we've got 57 uncovered lines total, and as you go down, the number of uncovered lines per file decreases. So this way you can kind of take a look and say like, okay, metadata trigger handler has 81% code coverage, but it still has the most number of uncovered lines. We probably should take a look at that one next. So this is just a ranking mechanism to help you adjust and sort your incoming work streams to help you better improve the health of the classes that are within your system. Then there's another section here where we have all tests broken down or ordered by their total test execution time. And that's broken down into method execution time ordered by individual method executions. So the metadata trigger handler test has all of these test class has all of these individual tests in it. And here they are with their individual test execution time that gets aggregated into the total runtime for the test. So by taking a look at just these kind of two sections, the ordered by number of uncovered lines and ordered by slowest performing tests, you can really get a good chance of, hey, where do we as an engineering team need to take a look at to improve the quality of our code coverage and the speed at which that our tests execute. So this is definitely a really helpful mechanism. Again, take the force source deploy results, save them as JSON, and then translate them into a dashboard. Save that dashboard somewhere within your deployment's artifact, and you'll be able to get some trends and some history about this is how it used to be. We made some changes, and this is how it's improved over time. So you can make data-driven decisions about your code quality and your code health. Another thing that we like to use are feature flags. So Salesforce doesn't have a native feature flagging mechanism, but we like to use custom permissions as our feature flag. Okay, so we like to use custom permissions because they can be checked throughout the entire platform. You can leverage a custom permission within the visibility criteria for a component that you have that's rendered within a Lightning page. You can check it within Apex, you can check it within workflows, you can check it within validation rules. So the general idea here is you basically take any feature that you're going to deploy and say, only implement that feature if the user has, say, feature ABC. And this allows us to then deploy that component up to the target Salesforce environment and then assign the permission set that contains feature ABC custom permission at a later point in time, thus decoupling our business go live from our technical deployment. So this is really, really great because then if there's something that goes wrong, you can just remove the permission set and your users are good. If there is something that you want to test with a subset of users, you can just assign that permission set to a subset of users. And then at a later point in time, you might add that custom permission to the user profile that they have to expand visibility to a wider audience. Feature flags are really, really cool. They're very, very helpful. Definitely would recommend using custom permissions as the feature flagging mechanism. So that way you can deploy your components today and activate them at a later date. Then another really, really cool mechanism that we've built are a thing called environment variables. So environment variables help to reduce the necessity of those long-lived sandbox-based branches. So within a Salesforce project, there are certain files that you may have that are supposed to contain values that are specific to a target sandbox. So for example, you might have a custom label called America Service Email, whose value is supposed to be different in non-prod versus prod. So for any one of these types of metadata that can contain the value that's supposed to be unique per the Salesforce environment, we create what's called a text proto. So protocol buffer is a data exchange format that we're really familiar with at Google. You could do this in JSON as well. You can see that the text proto is very analogous to JSON. So you could do this in JSON. I just have a text proto example. And we store one of these text proto files per target Salesforce org. And then we inject a Kokoro job environment variable that would say which is the target Salesforce org that I'm trying to deploy to. We'll use that to fetch the text proto of interest, and then we'll hot swap in the XML node values right before the deployment actually executes. So for example, we might have a text proto called qa.environment.textproto. Then our Kokoro job is going to inject an environment variable that says the target Salesforce environment is QA. So then we'll use the string of QA to fetch the text proto of interest. And that text proto might have something say, hey, the America Service email is supposed to be QA-Americaservice@google.com. And then right before the deployment executes, in memory within our build tool, we hot swap in the XML node value. So we keep americaservice@google.com as the custom label value within the XML. But then right before the deploy is executed, this environment variable gets injected from the text proto. So what this means is that you can take the contents of one branch of your repository and safely deploy it to multiple target Salesforce environments without the necessity of a branch that is specific to that target Salesforce environment. This is very, very helpful mechanism for us. And with the combination of feature flags and environment variables, we can unlock what we consider our ideal workflow. Okay. So our ideal workflow looks a little bit something like this. The legend is going to be similar to what we reviewed on the previous slide. But in our ideal state, developers are working in a Scratch org where they'll make their modifications, they'll build whatever components they need to, they'll raise a CL, and that CL is pointed at the main branch. So what we're talking about here is trunk-based development. So the CL will be raised to the main branch. At the time that the CL is created, we'll deploy the components to a Scratch org, and we'll use the Scratch org as our pre-submit environment. So we'll deploy all components, run all tests in that Scratch org. If everything goes well and you pass all of the rest of the pre-submit requirements and those automated code quality checks, you get the code review done, you merge it into main, and then when it gets merged into main, it gets automatically deployed to your non-prod environment. Okay. So then this little feedback loop just continues and continues. Your development team is always going to work in a Scratch org. They're going to check out the latest copy of the main branch. They'll make some modifications to it. They'll raise a CL that validates in a Scratch org. Once it goes through everything and you get code review and you merge it, it'll just get automatically deployed to the non-prod environment, and this loop just continues. Okay, this is where your developers work, and then it's important because it means that they never really need to do anything more after CL is committed one time. Then at some point within the application's lifecycle, say maybe a week later, once per week, you cut a new branch from main that corresponds to your version. So, hey, we're going to release version 8.1. And when that branch is cut, it gets deployed to prod. So you're choosing a historical commit from your main branch. You create a release branch out of it that gets automatically deployed to your production environment. Then say, this loop just keeps continuing. So people are continuing to deploy to main. They're continuing to test their features in a non-prod environment. Everything is good. This, a week after version 8.1 is done, we create a new branch from main called version 8.2, and then that gets released to prod. We keep that historical 8.1 branch for reference, but for all intents and purposes, it served its purpose, and we no longer interact with it. So this is how we do that trunk-based development on Salesforce. And then if something goes wrong anywhere throughout the process, then we'll use the git cherry pick command to cherry pick the change or the fix from the main branch into the most recent active release branch. And that's how we will enable, say, a hotfix deployment in case of a disaster. But the two strong prerequisites for this are feature flags and environment variables. This will enable us to do what we consider the ideal workflow. And once we have all of these mechanisms in place, our team individually, we're going to switch our version control system from Git to Piper. So Piper is trunk-based development. We're gonna try to make it work internally within our internal Google stack, and hopefully the end goal of that is to reduce friction between teams and to make it so that way anybody can contribute in a way that's familiar to them as a Google employee.
So there is one question, Mitch, like how you are making sure only a particular release changes are deployed from main branch to the prod, because main contain all or code base.
Yep. So we deploy everything from main. The key here is that you take your features and you hide them behind a feature flag. So you could have a production release of version 8.2 that contains features that are not yet live. And as long as they're hidden behind a feature flag, it's okay that they're deployed to prod. Then you use permission set assignments to assign those permissions to your users and enable your business go live at a later date. That's why feature flags are a strong prerequisite to this trunk-based development workflow.
One more question, like you say you are using PMD. Have you ever had override the PMD rule, or you are using the default rule only?
Great question, actually. So there is an ongoing effort right now for us, and I'll actually get to that on the next slide, about how we want to use custom PMD rules. So let me move forward here in just a moment. So this is kind of our ideal workflow. We're not there yet. This is where we want to be, and this is how the rest of the Google ecosystem operates. So this is how we're looking to operate at scale, and hopefully we can make this work. We'll keep you guys up to date with our progress. So just going to switch gears here into future challenges and endeavors. So there are quite a few things that our team is working on right now. And I just want to give you guys a little bit of an insight into what these are. And some of these things are, specific to our team or within the Google ecosystem. Some of them are just wider challenges to the broader Salesforce community. Okay. One of them is that, with feature flags, we want to enable phased feature rollouts. So roll this feature out to 5% of our users, then an hour later, 15%, then an hour later, 40%, then an hour later, 100%. That's something that we can do on the Google side, but we can't do that on the Salesforce side quite yet. Like I said, proper trunk-based development. That is kind of our ideal workflow that we referenced in the previous slide. Performance scratch orgs. Scratch orgs are great, but they're kind of tough to get started off the ground if you have been in an org-based development workflow for a while. And some things are that, like, they're not as fast to spin up and to use as one might hope. So we're looking to figure out ways whereby we can improve the speed at which we can create these ephemeral scratch org environments and populate them with all of our metadata. Some other things we're talking about are reconciliation mechanisms. So how do we safely detect the differences between what's in the org and what's in source, and make what's in the org match what's in source? Another thing is codify Apex style adherence. So within Google, we have this thing called the Apex style guide. It's just a document that specifies, hey, these are our variable naming conventions. These are how we write tests. These are all of the style that we expect to be applied to your Apex code. What we're working on right now is writing custom PMD rules to codify programmatically adherence to the Apex style guide. So that's where some of those custom PMD rules are coming into play. Another thing that we're working on is a hybrid package workflow. So you might have a repository that contains some unpackaged metadata and some second generation packages. How can you make sure that your pre-submit and your deploy jobs actually facilitate modifications to both unpackaged and to packaged metadata in a safe and repeatable way? That's something that our team is working on right now. We're also that readability requirement that I shared with you. That's really specific to our team, but we're looking to find ways to expand that to be the enterprise-wide readability requirements that's programmatically enforced for all Apex changes. And then finally, proprietary static code analysis. So outside of the scope of just PMD, right? We might want to write our own static code analyses for a variety of different source code formats that can be applied to uniquely to Google projects. But those are some of the things that we have on our roadmap and some of the things that are kind of open challenges to the Salesforce ecosystem. And that is all that we have to share with you guys today.